Good afternoon. So 1 year ago this week, we announced AWS Greengrass. 6 months ago, we released it to general availability. Since that time, we've been building our partner ecosystem and helping our customers bring AWS Greengrass to market. What we're going to talk today about is a few things. First and foremost, what is AWS Greengrass? Just in case you don't know what it is. We're going to talk about how to work with OEM and ODM and silicon manufacturers to bring your product to market, and also how to get things ready to operate Greengrass from the cloud. My name is Richard Elberger. I'm a partner solutions architect in the IoT segment. With me is Alex Gonzalez from Digi International. Digi is an APN IoT competency partner. So let's go ahead and get started. So like I said, the first thing that we're going to talk about is the overview of AWS Greengrass, how that fits into AWS IoT, and then some case studies that actually drive why we want to do things at the edge. The next thing that we're going to talk about is what are all the parts that are composed within AWS Greengrass, and how do you prepare to bring applications to market using AWS Greengrass? Next, we'll be talking about how to bring those apps to market at scale, because there's a lot of configuration items that you need to take care of when you take those things to market. And then Alex will be coming up here and giving a demonstration. So let's talk about some of those capabilities and case studies. First, let's roll back a little bit. What is AWS IoT? AWS IoT is an MQTT ingest service, highly secured, and operates well in the cloud. Things, much like this little chip right here, connects to AWS IoT with a secure connection, sends telemetry up into the cloud, and then you can do other things with that telemetry afterwards, such as big data and some artificial intelligence. So let's take a look deeper into that. So those things can be composed of many different types of items that you see out on the market today. It could be composed of my watch. It could be my phone. It could be your light bulb at home. Those items run with a very basic processor, and they can connect up to the cloud using a TLS 1.2 connection and mutual authentication. The protocol that we send those messages up to the cloud with is MQTT. So we generally use JSON-based payloads to send that information up into the cloud, into AWS IoT, where we have another component in the AWS IoT service called the rules engine, which takes those messages and proxies them to other backend AWS services. Now, typically what we'll want to do with that is send those messages to some kind of short-term or possibly long-term storage, so we can do other more interesting things with that data, such as analytics and machine learning. But then you have to ask yourself, why do we want to have something at the edge? What's the real driver behind that? One of the drivers is that we just can't get messages back and forth between the edge and the cloud to do some of the actuation that we need to do in near real time. Some of that work just has to be done at the edge in order to achieve outcomes. The next is economical. That really has to do with bandwidth costs and bringing that data up into the cloud, because if we're sending data at a high frequency, say for every single little device, and I could have 1,000 or 10,000 of these in my ecosystem, each one of these devices could be running telemetry at 10 hertz, just 10 times a second. And that could actually be very costly, sending up all that data to the cloud, and you may not need all that data up in the cloud. And then finally, there are some laws that you need to keep that data on-premise or within country. A lot of those laws have to do with healthcare and utilities. So let's take a look at going from IoT to the edge, what that means and what we've done in order to get that functionality that you need at the edge. One thing that we did is bring an MQTT broker to the edge. So you could use that little device that I just showed you, this one right here, the same one that was connecting to the cloud can connect to AWS Greengrass, okay? And you do that using MQTT and the TLS 1.2 connection. So it's a highly secure connection within your own ecosystem. The next thing that we have at the edge is AWS Lambda, which enables local compute in a way that your developers are familiar with, developing serverless applications in the cloud. And then finally, what we've brought down to the edge is device shadow, which enables you to run actuation and tell the device state that your device is currently running at. So for example, if your light bulb is off and you want to turn your light bulb on, we can actually determine what that change is and say, oh, we need to turn your light bulb on. And this device can subscribe to the shadow at the edge. Now, what's really good about that is now that you have it down at the edge and AWS Greengrass can function on its own because it has all those parts that you normally interoperate with the cloud, you can work in offline scenarios, and you can do a lot more interesting things at the edge in near real time. So some edge challenges that our customers faced were responding to events quickly. So if you're running, for example, an industrial ecosystem, you can't wait to send that message up into the cloud, do some compute, and send a response back to your system at your factory or whatnot. The next thing is that you need to operate offline. In many cases, actually, for example, weather stations, some of those weather stations will only have an uplink, say 15 minutes to a half hour a day. So what you can do is store all that telemetry locally, or need to store the telemetry locally, and then batch upload it once a day. What we found also were a lot of customers that started on the cloud and they wanted to develop at the edge were having challenges with a lot of the traditional programming paradigms that were going on in embedded programming. So we wanted to help our customers get things going at the edge by leveraging AWS Lambda. Also, we wanted to ensure that customers had the ability to send telemetry, only the telemetry that they needed to send up to AWS IoT, so they didn't have to send everything up there, thereby increasing costs, maybe gratuitously. So we wanted to reduce those costs for our customers. And then finally, of course, we needed to ensure that our security was in place. The same as we had with AWS IoT, we wanted to ensure that not only was that connection secure between AWS Greengrass and AWS IoT, but all the devices that were connecting to AWS Greengrass were also secured. So let's take a look at some customers that have leveraged AWS Greengrass in the field. And the first is Rio Tinto. Rio Tinto had a real challenge where they needed to, in near real time, determine if there were problems in the road that they were driving down. Because those tires are really huge and they're really expensive. So once you damage them, it's a huge cost. So they wanted to ensure that they were able to maneuver around bad road areas quickly and also report the damaged roads back centrally so they could send out work teams. And the next is Nokia. So Nokia's edge compute enables them to have real-time video for their customers. For example, if they're out in a stand watching a Formula One race, also they could be watching the race on their phone, for example, the driver's perspective. So Nokia also wanted to have that capability of putting in Greengrass in there to do some edge compute, for example, analytics. Next is Pentair. where they have, what they do is filtration systems for beverage. And they wanted to use Greengrass to do a lot of cluster compute at the edge and ensure that they were only sending the right data that they needed to up into the cloud and do analytics on that data. Next is Stanley Black & Decker. And this is a really interesting case, and maybe it resonates more with folks in the room because maybe many of you have used their drills. So what they're able to do with AWS Greengrass as a gateway within the home is determine if the battery within the drill is getting too hot or if there's too much vibration. So they can use AWS Greengrass to do that compute locally, send an alert, and also interact with the device itself. And then finally, there's Cone Cranes. And they're using AWS Greengrass to locally determine better ways to maneuver their cranes. So taking a look at that, we're covering a wide spectrum of verticals in the industry, right? Over the last, since we've released, we've been covering or touching nearly every single vertical out there. But in order for us to achieve that, we had to have a great partner ecosystem. We need to build partners at the operating system level, at the silicon level, at the distribution level, at the communications level. And if we didn't help our customers piece all that together, it may have been a little bit overwhelming. So what you'll be able to see later on in this talk is how you progress through that train of thought and how you want, like how deep you want to go, how granular you want to go in deciding what kind of design that you want to put into place if you want to use commercial off the shelf or whatnot. So at launch, we had all these partners. We have Digi here today. They were a launch partner 6 months ago. And we work with partners such as Samsung, QNAP on the consumer side, so they have some really cool in-home sandboxes. They're also for small business as well. And this list keeps on growing. So let's talk a little bit about AWS Greengrass. And first of all, what I'm going to talk about are the low-level components within Greengrass itself. So the first thing is, what's a Greengrass Core? If you've been dealing with Greengrass for a little bit, maybe you have a handle on it, but what the Greengrass Core really is, and well, let me just click forward. So actually, it is an operating environment, much like middleware, that runs on a physical device, like this device right here, running on embedded Linux, but it is your hardware. So that brings about an interesting conundrum, because for those of you who have been operating in the cloud to date, you've been relying on something called a shared security model, and this is a new thing for you. In the shared security model, when dealing at the edge, the hardware is your baby, right? So this is an additional item that you're going to need to cater for when working with AWS Greengrass. So it is composed as an operating environment, which means that there's a programming runtime. When you install AWS Greengrass, it comes bundled in with the MQTT broker, AWS Lambda, and device shadow functionality, all in one. What's cool about it, though, is that it talks to the cloud just like any other IoT device would. And in doing so, what we've set up is a way for you to feed additional configuration to AWS Greengrass after you deploy it. And we compose these into configuration items called Greengrass groups. So whenever you create a configuration change, literally you can just click the deployment button, and AWS Greengrass at the edge will consume that change. But again, it uses the TLS 1.2 mutual authentication. We need to ensure that we're using that security. I keep on drilling that in. It's very, very important that you're aware of that. But what's cool is that Greengrass doesn't only interoperate with AWS IoT. It can also interoperate with nearly any AWS service. But how does it do that? So it has a special feature called the token exchange service, where you're able to receive an access key and a secret key just like you would using the SDK, but it does it on the fly. And however which way that you configure your IAM role, that will give you access to one or more services that you define. So you have complete control over what your device at the edge can access in the cloud. Another thing to note is that AWS Greengrass is not an island. So it is running on an operating system that you control. So a cool fact about that is if you want to use Redis locally on your device at the edge, AWS Greengrass will interoperate with that. You can make a Redis connection just like you would using any other application, but you can do that from Lambda at the edge. So speaking of Lambda, you can run Lambdas like you do in the cloud today. But one additional feature that Greengrass has over Lambda in the cloud is the ability to run long-running Lambdas. What does that mean? It means that you can start executing a Lambda at the edge, and it can just run in a while loop, much like how you would run code on bare metal. So that's pretty good. That means that you can actually just listen to events coming in, and it will execute on demand rather than relying on routing, which I'll get into in a little bit. So let's get more detailed about what it means to be at the edge and working within a device ecosystem. Because really what we want something more than just having this gateway running at the edge and just humming along. We probably want to do something a little bit more exciting by connecting a bunch of little devices to this gateway. So the way that you go about configuring that, I'll get into the details later on about Greengrass groups. But the configuration item for this is that you can have n number of devices configured for a particular Greengrass core. But they have to be defined within the Greengrass configuration. So that doesn't mean that any old device can connect to the core. It also means that this device must be TLS 1.2 mutual authentication capable. Okay? So what does that mean also? It means that in order for Greengrass Core to understand the configuration, you must also have a certificate configured for this device and registered with AWS IoT. But that brings together a conundrum. How does this device know to talk to this gateway? Well, there's two ways that you can go about achieving that. You can hardwire it into your device to talk to the gateway, so you know where the endpoint is. But we have another special feature in AWS Greengrass, which is called auto discovery. If this little device has the ability to go talk to the internet, go talk to AWS IoT, it can understand what the endpoint is, the IP address of this device, and then have it automatically configured. But what's the issue with that? If you're in a closed M2M environment, this device will never be able to reach out into the internet, right? So there's additional programming consideration that needs to be made when you do non-auto discovery development. So next, let's talk about routing. Well, in contrast to the way that we do MQTT in AWS IoT, where if a device has access through the policy to talk to the MQTT broker, you can send it up there, and then the rules engine just takes care of it after that point. Greengrass is a little bit different. What we need to do is define routing rules or subscriptions within AWS Greengrass. And what's cool about that is now we can start micromanaging how these devices can talk to each other and how we can route messages to do something useful. So the first thing that I can do is route a message between devices. So I can have this device here talk to this device here, but they're both talking to AWS Greengrass. But Greengrass can route that message for you. The next type of routing that you consider is just going straight to AWS IoT. So I can set up a rule within a Greengrass subscription which says anything that comes from that particular device into AWS Greengrass, I want to automatically push into AWS IoT. So if I send to a particular topic to Greengrass out of the edge, it'll send it to the same named topic up in the cloud. And then you can take care of it the same way that you would with AWS IoT applications using Rules Engine. Probably the most interesting one, though, is with Lambda functions. So I can take a message from a particular device and push that to a Lambda function, and that Lambda function consumes it and enables you to interoperate with it as an argument in the code block. What's also great about Lambda at the edge is that I'm able to return a value or even publish to various topics, and that will automatically perpetuate to other items in your ecosystem based on the rules that you defined. So it's not just device to Lambda or Lambda to device. I can actually go Lambda to Lambda, or I can go Lambda to cloud. Another cool thing about Lambdas, though, within AWS Greengrass is that you're able to call Lambdas from within Lambdas, like subprocesses. And last but not least is device shadows. So just like you would operating with device shadows in AWS IoT, you can operate with device shadows at the edge. But you need to define every single shadow that you want to interoperate with, okay? That means that if you want to have your device interoperate with the shadow, you need to set up subscriptions for that. If you want your Lambdas to interoperate with the shadow, you need to set up subscriptions for that. I just talked about being able to return a value from a Lambda. If you want that return value to update a shadow, then the route would be pushing the message from Lambda to the shadow via some defined topic. So let's talk about device shadows in a little bit more detail and why it's really cool to have device shadows at the edge. So let's take a normal scenario that many of you may be familiar with. I'm going to send a message up into the cloud, and I'm going to just put it into DynamoDB. And I may have a client application that's on my phone, of course authenticated with Amazon Cognito, so I'm able to talk to that shadow in a pretty nice way by defining my policy in Cognito. And I want those devices to be able to interoperate with the shadow. For example, turn the light bulb on. I can pull down my blinds, turn off my air conditioning from the other side of the planet. Now, before AWS Greengrass, let's take the blinds, for example. Those blinds in your house would have to have direct internet connectivity, which actually gives your home more exposure. Using this particular method, now your blinds would be talking to Greengrass, subscribing to the shadow, and then being able to understand, should I bring the blinds up or down, based on how you define it in your cool little app, right? So the feature I want to hone in on here in Greengrass is shadow synchronization. What you're able to do is configure Greengrass. If your device makes a change to the shadow, well, let me put it this way. Let me wrap it back the reverse way. If I make a change to the shadow with my app, pull the blinds down, Greengrass will automatically replicate that shadow change down to the edge. If that also includes a delta value, which means I have to do something, then my blinds would be subscribed not to the shadow in the cloud, but to the shadow within my gateway in my home. And then it will be able to actuate on that. Once the blind movement is done, then it can report back to the gateway. The blinds are closed or whatever. And then that shadow state would get replicated back up into the cloud. And then you would get that updated up on your client app. Let's talk about Lambdas a little bit. So Lambdas in AWS Greengrass, as of Greengrass 1.1.0, supports 3 programming languages. This is in contrast to the multitude number of languages that are supported up in the cloud. We support Node.js, Java, and Python. So once you develop that Lambda up into the cloud, you can test it in the cloud, make it as part of your Greengrass configuration, and deploy that code to your Greengrass device. Now, if my device sends a message to a topic, now what I can do is send that message that came from the device to the topic, to Lambda, and perform some interesting work, such as go fetch me my picture. Could be any picture for a photo album. It could be a music file. It could be your family video. And now I can talk directly to S3 using the token exchange service, which means that I don't have to add any additional credentials locally on the gateway in order to achieve that secure outcome. So let's talk about how to get what I just laid out on you. How do we get that from concept and proof of concept, maybe on your development board, out into the market, and all the things that you need to consider to achieve that? So let's talk about the layers that you need to consider. The first layer is hardware and the board support package. So each one of these boards, and I'm going to pick up a different board this time. This happens to be BeagleBone Black with a Satara processor. And Satara comes from Texas Instruments. And this particular processor has its own board support package. So if you were going to construct a custom operating system for this particular board, you would need to take the BSP and compile your own version of Linux in order to achieve that. But once you do that, identify what hardware that you're going to have, and you're not going to ship BeagleBone Blacks to your customers, right? You may be using the BeagleBone Black to evaluate the Satara processor, and then develop your own PCB with the peripherals in order to achieve the product that you want to go to market with. So once you go through all the work of constructing your Linux image and getting that flashed at the factory, it's going to be very, very rare that you're going to change a lot of the fundamentals of that image, because it's very difficult for your customers to physically change the hardware. So once it's done, it's pretty much done. But then you have another layer on top of that, which is the operating environment. The operating environment is, I generally consider that as the Linux kernel plus all the ancillary files plus any kind of middleware that you want to put on the image. And this too is very rarely upgraded. Well, I would say rarely. So you may have heard some about over-the-air updates and that sort of thing. I'll talk a little bit about Yocto later on and how that's achieved. But this is not a trivial thing to do. And it's fraught with a bit of danger, because if your upgrade fails, then your customer may be left in the lurch, right? So this also takes a lot of additional engineering. So the way that we're positioning Greengrass then is actually working that at the application level so we can do more iterative development. Instead of having to flash firmware upgrades down to your customer's devices, now what you can do is make a modification to a Lambda function, put it through dev and test just like you normally would, update it as part of your Greengrass configuration, and deploy it. And then also what that means is it's also very easy to recover because it's not impacting the upgrade flash process. It's all at the application layer. So there's some big questions you're faced with. Can I use commodity hardware? Or should I develop my own hardware? Should I be building my own Linux distribution? Because Greengrass runs on Linux on a few different processor architectures only. Should I be building my own, or can I take something off the commercial, off the shelf, or can I OEM something that's already on the market? And then finally, when you're putting your product to market, you need to understand the kind of regulatory constraints that you're faced with, and this question will actually influence your decisions on the prior two. Let me give you an example. If you are operating in a low-power environment, you may not just be able to slap on a copy of Ubuntu on whatever device that you happen to have. First of all, you have really no control over a lot of how those fundamentals are actually compiled, right? And you may also have a difficult time operating in low power modes. You want to operate in low power modes because that actually increases the lifespan of your device, something that you want all of your products to achieve. So these are the big questions that you're faced with. So what's the process that you need to go through? Well, the first thing that you have to think of is, what are the components that I need to get my product to market? What kind of compute do I need at the edge? What kind of storage do I need? How much flash storage do I need in order to operate my application? You may need also use some boards for that evaluation. So for example, the BeagleBone Black, like I showed you before, is one reference board, but I have another board here from Digi, which has their custom NXP module on here. It's actually called a CCIMX6. And this is an evaluation board. So you wouldn't necessarily take this board and send it to your customers. First of all, they probably wouldn't know what to do with it, right? You may need to take that module and customize it on a PCB to wrap it with your own enclosure. And these are all decisions that you have to make. So you have to go get services to design your enclosure for that particular form factor and so forth. And then depending on how many of these units that you're putting out to market, you need to contact a manufacturing service. Those are worldwide. There's huge conglomerates that deal with that. But what's great is that we've been building our partner network in order to include all of these so we can help our customers get their applications to market. And then you have to think about packaging and distribution. So let's wind that back a little bit. When you're talking about component evaluation, there's a wide variety of silicon providers out there that enable the compute that you may need to operate in, but each of them have their own special features, maybe better security or better low power mode or operates in really extreme environments. Those are the types of components that you need to drill down on in order to identify what you need to use to bring your gateway to market. Now let's talk about specialized operating systems, because this is what we're finding. Well, the customers that I work with partners, but those partners work with customers, and when I talk to them, the first thing they ask is, does it work with Yocto? Does it work with OpenWRT? Why is that? It's because they always want to micromanage their operating system in order to fine-tune like the number of attack vectors that are possible on the edge, or fine-tune energy consumption, that sort of thing. So we need to understand what type of constraints that we have in order to operate. That actually also feeds into cost. You need to identify what kind of kernel you want to use. So I put a few different kernel types in there, but because we're talking about AWS Greengrass that will only run on Linux, which is monolithic kernel, so if there's other kernel types that you need to take care of, Greengrass wouldn't work for you. There are other solutions out there that would work. And then you need to think about upstream or downstream packages that you need to fold in to your distribution and what the impact has for you on maintenance. So I'm not sure if I mentioned Redis before or not, but I'm a Redis fan. I love working with Redis on the edge with AWS Greengrass. But what would using AWS or using Redis at the edge mean to my upstream and downstream packaging impacts and maintaining that moving forward? Then I have to understand how I'm going to get that image that I'm constructing for the specialized operating system first at the manufacturing site. So you have to send your image to the manufacturers to get your module imaged before your product actually gets shipped out to market. And then you should also have an upgrade plan in place already. So say, for example, well, I said before, you may very rarely or rarely upgrade your operating environment. But definitely, if there's a security impact for the image that you've constructed, like a security alert has come out for a particular package that you've chosen, then you'd want to take that security fix and roll it into a firmware upgrade. So you need to have that stuff sorted and in place. Okay, and I talked about that a little bit. So let's talk about Yocto Embedded Linux and what that means. So it's no magic. How does my software understand what is on this hardware? And there's a magic, I shouldn't call it magic because it's not magical to the people that deal with it every day, but there is a thing called a device tree that gets configured as part of U-boot. U-boot is also what's used to start up the Linux kernel. Now, U-boot isn't the only one out on the market. There's a lot of bootstrapping programs out there that you can choose from, some of which are commercially supported. But U-boot seems to be the most pervasive in the market. And then Yocto has this thing called the Pokey Core. I really like that cute name. But what you'll see if you go up to the Yocto Embedded Linux site is that Pokey is really the base. It's a lot of really cool build tools, plus a run book of all the packages that you would need to build a base Linux image. But then you need to add specialized peripheral support and component support. After all, if I was just creating a processor that didn't have any value-add peripheral or component support, especially if I was creating a single board computer like this one here, then there's much to do about nothing. But in order to achieve having the capability to write applications to work with that board, the manufacturer or the provider, the silicon provider, needs to give you something called a board support package, which is effectively a lot of the drivers and value-add applications to get you going. And then usually what that provider will do is give you a demo application to get started quickly. Now, if you go and do this yourself, the first thing that you would do is take that whole package that's wrapped up, rip out the demo app, and start writing your own app, and start going to town. But it actually may get a little bit more complicated than that, because if you take, for example, this, that's why I brought the Bigelow in black. It's a very cool, popular board, has a Satara processor, but here's the deal, is this has a BSP specifically for this board. If I go and create a new PCB and put the processor on there, I would have to tweak a lot of those things in the middle. So I just want you to be prepared for a little bit of the challenge that you would have when you're going to market. But our partners are there to lead you through the way. And then finally, let's get going on Greengrass group deployments. So there's 4 key parts in a Greengrass configuration. Of course, the first one is the Greengrass Core configuration. If you don't have a Greengrass Core, then, well, nothing else would make sense, right? Within a Greengrass group, there can only be one core defined. So we don't support multiple cores within the same configuration. Next is a device definition. The device definition then takes the configuration of how many number of components that I want to talk to my core. Then you have an AWS Lambda definition, is all the Lambdas that I want to ship down to the edge. Finally, the subscriptions. How do you want to route messages? Which messages are going to go up to the cloud? Which ones are going to be processed by AWS Lambda? Those are all defined in routing definitions. Now, in order to deploy this, what Greengrass does is says, oh, I see your Greengrass group configuration. Once you click the deploy button, it says, okay, I'm going to package all this stuff up. So it packages up your group configuration plus the physical Lambdas that you've defined as part of that configuration. And it takes that package down to the edge, first does a verification, because now you can start to say, oh, wow, there could be something interesting happening here where someone could tweak that code while it's in flight or stop the process locally. Actually, what we have within the core is it does a lot of SHA checksums and so forth to ensure the integrity of those packages so they're not tainted between the cloud and AWS Greengrass runtime. And it ensures that the function is properly coded and so forth. It gets loaded, installs group.json. I don't know why I put the file name there, but actually what happens is that all that configuration that you see up in the cloud gets wrapped up in the Greengrass core. That actually gets placed onto the file system as a configuration called group.json. And then it restarts AWS Greengrass. So there's a little blip in time where your Greengrass devices may not be able to contact the core. But what's cool about that is that those Greengrass devices that are talking to the Greengrass core, they are using the AWS Device SDK, just like you would interoperate with the cloud, which means that you have queuing and retry and all that kind of stuff that you have today when working with the cloud. So then what you think about is, well, having one gateway is fine. Maybe having 10 gateways is fine. But what do I need to do in order to put out to market 100,000 gateways or 1 million gateways? Because that's a lot of configuration that you need to go through. Well, what we've been helping our customers with is creating some automation around AWS Greengrass to help facilitate the Greengrass group configuration and delivery. First of all, what we help them do, because all of this is pretty bespoke right now because Greengrass is relatively new. So we'll create a programmatic template, which is effectively a JSON file. What these would look from a core perspective, but it would be templated out. So things that are specific to a device or specific to a particular core thing name would have a variable. And then what we would get from once your customer gets a gateway, there would be an onboarding event. And then combining those two together, we can construct the Greengrass group on the fly. We can deploy it to the edge. And then they're all nicely running. Okay, so we can do that as one-offs. We can do that as groups. It depends on your particular use case and how you're going to market. But now the challenge is, how am I going to update stuff? So I need to have the same kind of programmatic update to upgrade those thousands or tens of thousands or hundreds of thousands of groups. Because remember, one Greengrass group has a one-to-one relationship with an actual physical device. So then I can go ahead and deploy that. Another interesting point that you may want to consider here is, what do I do when I send out hardware revision 1, then a year later I send out hardware revision 2, which has some value add? Then how do I manage it? Well, it may be using most of the same functionality, but that value add may run another Lambda function, something like that. How would I do these kinds of updates, the programmatic updates, in that case? Well, in that case, what I would suggest is you use thing attributes within AWS IoT to annotate those devices, like the model number and so forth, and then based on that, you can change the Greengrass groups accordingly. So what's cool next is the more exciting stuff. We're going to do demo time. So Alex?
But stay here with me because I have to hook you up to the machine. First, I'm going to check the setup. So we should be able to switch between the slides and a video stream that we have that's pointing to the actual demo. See if that works. OK. So you can see the demo there on your right. This is the demo. And they'll take the chance to start to hook you up.
Oh,
okay. So cool. We have 3 different healthcare sensors. We have a respiratory rate sensor, which you have to wrap around your chest. It expands and contracts with your breathing. So you have to make sure that it's just around your lungs.
It's wrapped
up. Tell me if it helps.
Yeah, so it's one of those months where you wish that you worked out more. So 1 second. Yeah.
Not too quick.
Yeah, not yet anyway.
Okay, so the second one, we have a heart rate sensor, which is just a clip in your finger.
Yeah.
Okay, the cable goes up. Yes, and the last one is a temperature sensor, which you can just hold between your fingers, assuming your hands are warm enough.
Yep.
Okay, so that's the setup. Go back to the slides. Okay, so hello everyone. The idea behind this demo is to show how we can help our customers build AWS solutions using DG hardware and software for a reduced time to market. I'm going to need, yes. Okay, the background, the scenario we're looking at is a field hospital, the type that is set up after some type of natural disaster, like an earthquake or a hurricane, with a limited number of medical staff. So we have to make sure that they can focus on those patients that need it the most. What we propose is a continuous vital sign monitoring system, which is going to avoid the need for the medical staff to go to each individual patient and check the vitals every few hours. We sample, store, and use the data locally, and we also send it remotely to the cloud. The building blocks for this demo, we have the smart patient node, which is the part that it's attached to the patient's bed when they come into the hospital. It has the medical sensors, as we've seen. So this smart patient node is sampling the medical sensors, heart rate, respiratory rate, temperature. It has a display with a number between 0 and 4, which is an early warning score, an indication of the patient's condition. And it also has an alarm, which is a sound that goes off when there's a change on the patient's condition, so when there's an increase on the early warning score. What we're going to do now is we're going to go back to the demo. And it's been on virtualized mode, so it's using virtualized data of an ideal patient, which is laying on a hospital bed. I'm now going to switch to the real sensors, so we might have a change in early warning score, depending on the status of Richard.
Yeah.
Okay.
Uh-oh, I'm a 3.
Like that, you have to calm down.
Okay.
Yeah, you have to breathe. Okay. Calm down. Yeah, we'll come back to that.
Okay. It's probably my heart rate.
Okay, so the next component is the Smart Hospital Gateway. This is the edge device. So this is the device that is getting the sample data from the smart patient node, and it's performing the early warning score calculation and also the status calculation for the alarm. It has a local display, so it aggregates the data for the different beds. This is what the local nurses would use to react to a worsening condition of a patient. And it also sends the data through a Cat1 cellular link to the cloud. What we can show now, Richard, is that
I'm not changing.
no, you can try to hyperventilate.
Oh, it went to 2.
Simulated,
You
yeah,
gotta
you will
switch
come
it.
down. So it has a sampling rate of 7 seconds.
Oh, that's because I took my hand off the.
Oh, okay. So
Okay.
we can show it working.
It was at 2 for a
If
second.
you first calm down and then you start to hyperventilate a bit. You might have to hyperventilate a bit more if you wanted to change from 3. Yeah. I think 3 is pretty high already, so okay, there it goes.
So how is that running? How is it checking or changing this?
So the computation, the smart patient node is sampling the data, and it's sending just the sensor data to the edge device, which is doing the calculation of the early warning score, and it's sending that on a MQTT topic, both up to the cloud and down to a device. So it's actually being told.
Yeah, it's using Lambda to do that, right?
It's using Lambda, yes.
Yeah, okay.
It's using Lambda. Okay, so let's switch back to slides. Okay, so the final part of the demo is the cloud application, which consumes all the sensor data and all the status data that come from the different hospitals, so the different smart hospital gateways. It stores that on a NoSQL database, and it also has a user interface, which is the interface that the remote respondents are going to use to check the conditions of the patient. So if they have an alarm, they are not on site, they can still go to the application and check the vitals, check the early warning score, and decide what type of action to take. We have a tablet running the user interface over here. So I might have to move it. Okay.
Yep. Just move whatever.
Okay. I hope you can see it. So that would be an example. We have the different graphs for the different respiratory rate, heart rate, and temperature. We also have an early warning score, which you just removed out of the screen, I think.
Yeah. No.
And
okay.
If there's an alarm, would have an indication. So this, as I said, would be used by the remote respondent teams.
So I just
You
went,
cannot move so much.
Yeah,
You're a patient in
So I
bed.
was at 2, and then it went to 3. Now I'm going up to 4 because Alex is scolding me.
Okay. Okay, so just summing up what we've just seen, we've shown that we are able to capture data locally, send that to an edge device that is performing the computation of the early warning score and the status. This part works offline, so it doesn't have to be connected. If it's disconnected, it will cache the sample data and will send it up to the cloud when the connection is restored. And we've also seen that we send all the data up to the cloud for further study. Things that I can think about, for example, seeing how the reaction to the natural disaster has been, if there's anything that could be improved, or to load balance the medical staff between different hospitals based on the real condition of the patients and the type of medical care that they actually need. So that's all I had.
Yeah.
You can
Cool. I can
unpack. Thank you so much.
Okay, cool. Thanks, Alex. That was awesome. So let's kind of wrap up what we've...
That's very annoying.
He's dead. See, I unwrapped myself. Now I'm dead. That's why it's beeping. So let's just kind of wrap up here what we discussed through this talk. What we discovered throughout this particular talk is how we can connect systems not just to the cloud, but also what we can do is curate M2M networks using AWS Greengrass and using AWS technologies such as AWS Lambda. So that means that a lot of these skills that you or your teammates have built up over the years can be leveraged when building edge solutions. What we also talked about are considerations that you need to make when you're building solutions. This could be internal solutions, programs of work that you need to put out, or millions of products that you want to sell. But in each of those cases, they'll be unique because your customers have unique requirements. And then finally, we took a look at what you'll need to plan for in order to automate your ongoing operations when using Greengrass for your customers. So with that, I'd just like to end up saying thank you very much. There's my contact information up there if you would like to get in contact with me. Alex's contact information is there as well. Digi International, the hardware that you saw today, they have a booth at the ARIA. The booth number is there, 209. You can go speak with them there. Some of them are also here in the audience, so if you want to speak to them after the session, feel free to do so. And there's a couple of more sessions that you may be interested in about Greengrass. Of course, I'm not sure exactly if they've occurred or not yet. So if they've occurred, of course, they'll be viewable on YouTube. And thank you very much. It's been a pleasure.